Right, and now this is where it goes to the application part of the maths, okay, using calculus. So problems involving maximum and minimum values. Just stay with me, this video is going to be a little longer than normal. We now focus on some real world applications of calculus. For example, we can find the maximum or minimum area or volume, as well as minimize variables like cost, perimeter, and so forth. Before discussing the examples of maximum and minimum values, it is advisable for you to complete the investigation. Right, in order to maximize or minimize an object, a to the x, determine a prime x. Okay, so they're saying first step, before you even look whether it's maximum or minimum values, right? A to the x, they say do a prime x. So they're saying do a derivative on it, okay? Equate a prime x to 0 as the next step. So notice with the parabola, don't we do that? And also with the cubic function. So find the turning points, what we do, so they gave us f of x, so in other words a of x, and then f prime x, and then the very next step to find the turning points, we then let that equal to 0. So please note that the method is exactly the same like a turning point. Okay, the values of x obtained then be investigated to establish whether they will yield a maximum or minimum values of that given object. Okay, so what they mean there, when we get our answer, we then substitute it into the original equation, and then we get the two turning points. One is a maximum turning point, one very on the top, right? You're looking at the y value, and the other one will be a minimum turning point because of that negative y value. Okay, for example, on the Cartesian plane. So one will be up, one will be down. And so that's your maximum and minimum. So simple. So what we are saying, it is exactly the same thing. So let's just go there so you can have a little view of increasing all the way up to there, and then it is decreasing after that. Okay, so that's your maximum turning point, and then it decreases all the way, and that's your minimum turning point, and then it goes the opposite way, then it goes the opposite way again. Okay, can you see that line there? Right, and so what happens to get this point, we do a derivative, we find x, okay, and we take that x, we let it equal 0, we find x, and we substitute x into the original equation. For this point, we do exactly the same. Okay, f prime x, we get the derivative, we let it equal to 0, solve for x, take x, and substitute it into the original given equation. Okay, then something called a point of inflection. So the point of inflection here is that here, you do a derivative twice, okay, and solve for x, and that's how we get the point of inflection. Alright, let it equal 0 and solve for x, points of inflection. Okay, very simple. Alright, so going there, points of inflection, right? If the cubic function has only one stationary point, this point will also be a point of inflection. That is a stationary point. Refer to the shape to see what kind of point of inflection it is. Right? For points of inflection that are not stationary points, find the second derivative. So you do a derivative again, and then you let that equal to 0, and you solve for x. Okay, so let's look at a calculation for the points of inflection. Alright, so for points of inflection, given this was the equation, 3x squared minus 12x plus 9. Do a first derivative, you will get this. Okay, so notice it was a cubic function, the first derivative, you're going to get this. Notice f prime x, right? So the question was something else, obviously. Here's the question here. F of x is equal to that. You with me? Then they say calculate the points of inflection. So the points of inflection, you do a derivative, you get that. You do a derivative again on the not on the original, but on that. Then you got that, let it equal to 0, solve for x. Take your answer and put it into the original. So now you got x is equal to 2, substitute f of 2, put that into the original question, okay, and then you get an answer of 2. Therefore the points of inflection will be x was 2 and y. Notice the answer was y, which is 2. Okay, so all you're going to do for points of inflection, do a derivative on the original, that's your answer there. Then you're going to do a derivative on that, let it equal to 0, solve for x, take x, put it into the original, you're going to get y, and so x was 2 and that was y. This was the original question over here. Okay, is it that simple? That's a point of inflection. So now we're going to go to maximum and minima again. So you can see it's the same thing. So for maximum minimum, they said what you must do, right? Where does it say that again? Do you see it? It says it in the square. Rule for determining the maximum minimum values. Notice, let's read it. Determine a prime x first and then equate that to 0. That is exactly the method of returning points. Okay, so you're not doing anything different. Right, let's look at this two-dimensional problem. So here it says two-dimensional problems, example 24. So you're given a rectangular area is to be closed off on the 3 sides by a fence and an existing hedge. So this here is the garden hedge, like a cherry tree that's been shaped into a hedge, and here you have your 3 sides of the fence. So your 3 sides are x, y, and x again. Why x and x again and not x, y, z? Because if from there to there is x and there to there is x, what do you know if 2 variables are the same? This means that these 2 sides opposite each other have exactly the same value. So that's why they're calling it x and x. So they say find the maximum area. Okay, find the maximum area of the rectangular area and its dimensions if 100 meters of fencing is available. So for the fencing to work here, if you look at it, for the fencing to work, we know that that x plus that y plus that x must all equal to 100. Okay, must all equal 100, because the fencing is only going to go from there to there to there, and the hedge is serving as the other side to close the area off. Okay, so it's this side plus this side plus that side will give me 100 meters of wire. So the first thing I'm going to do is calculate the area of the box. Area is equal to x times y. Now in the question it said that the perimeter of the fencing will be x, y, and x as seen in the diagram, and all of that must be equal to 100 meters. Simplifying the maths, we'll get 2x plus y is equal to 100. And so we get 2x plus y is equal to 100. Don't forget, we said that x times y was equal to the area also. Plus 2x will become minus 2x on the right hand side. Area is equal to x times y. So let's substitute the y where y is. Y is 100 minus 2x. Using the distributive property, x times 100 will give us 100x. The sign will remain the same. X times 2x will give us 2x squared. Do note that the question said for maximum area. So for maximums, like explained before, all we do, we let that equal to 0. Okay, for maximum and minimum, we let it equal to 0 and we do a derivative on the question at hand. So 100x, don't forget the derivative of 100x will be 100 because we chop the x, and then minus 2 times 2 will give us minus 4x. The exponent is 2, minus 1 from the exponents will give us 1. X to the 1 is 1. And so that is the derivative of the given question. Right, so now we're going to let that equal to 0 for maximum and minimum values. And then we're going to solve for x by bringing the minus 4x over to the left hand side. It will become minus 4x will become plus 4x. Divide both sides by 4, we'll get x is equal to 25. This means we've now solved what x is. X is equal to 25. Now to find y, we'll have to substitute x back into the original question so that we can get the y value, which would be the breadth. X is the breadth and y will then be the length. So our original question was 100 minus 2x. So let's substitute x is equal to 25 by x. So this will be 100 minus 50. This means y is equal to 50. Y is definitely equal to 50. Now don't forget our original there we had was a to the x is equal to 100x minus 2x squared. That was the original question. And so we want to substitute the x value of 25 into there to find the turning point. So do you agree that a to the x there, 100x minus 2x squared, is actually a parabola? Think about it. So all I have to do is switch those two around by putting the x squared first. Notice that is a parabola and it's a negative parabola. So in other words, negative parabolas are unhappy and they produce a maximum turning point. Let's see it. So negative parabolas, that means there's a negative in front of that 2. So if there's a negative, it's an unhappy parabola. Let's just draw a Cartesian plane so it can make more sense. So that point will be the maximum turning point. You agree? So for us to get a maximum, notice that we did let it equal to 0. We did let it equal to 0 after we did the derivative. We then got an answer of 25. We can take that 25 and substitute it back into the original question. And this will give us the maximum y value. In other words, the maximum area for that given rectangle on the left hand side. And punching all that into your calculator, you will get 1250 meter squared. And so that is now the maximum area of that rectangle. So notice we also found the dimensions, as you can see in the picture, 25, 25 and 50. So those are the actual dimensions of that shape, and the maximum area it will produce is 1250. Now going back to grade 8 and 9, who can tell me what is the formula for area? Area is equal to, right, so area is equal to length times breadth. In other words, in this case it will be x times y. Substitute the values 25 times 50 and you tell me. Punch it into your calculator. So according to my calculator, 50 times 25 is 1250 meter cubed, meter squared. Do note we get exactly the same answer. So do note how we used calculus to calculate the maximum area for that rectangular shape. Okay, and so maths is really amazing if you totally understand it. We get the same answer. Okay, and there you have it. Right, do note class, I did give you a worksheet on this. This is the last example on that calculus work that I gave you. Right, I am going to make another video with the other two questions, as that time has been a bit of a problem. I'll get back to you soon. A box is made from a rectangular piece of cardboard, 80 centimeters by 40. So 80 centimeters, where do I get these numbers from? By 20. So 80 centimeters by 20 centimeters by cutting out the shaded area and folding along the dotted lines as shown in the diagram below. So if this box was folded, it would become this box, in other words. So they say express the breadth B in terms of the height. Okay, so this means we'll have to look. Express the breadth. So in other words, breadth is equal to. So here we go. Okay, so there can you see we got B's here? Breadth. Okay, so think about how you're gonna carry on with this question. So they, in other words, they're saying you won't be able to solve for the breadth, but you can let the breadth is equal to something. So do note that all of this is equal to 80. So here's a tip. we got h plus b plus h plus b, and all of that is equal to 80. And on the other side, the vertical side, we have h plus l plus h is equal to 20. So that's a starting point for you, and then manipulate it to find what is equal to what. Hence, so from 8.1, when it says hence, it means use the idea of 8.1 and add it to 8.2 in order to get this. Okay, try it out, pause the video, try it out on your own. 8.3, determine the numerical value of h. So in other words, they mean solve for h. Find out what h is in order to maximize the volume. So when you get two answers after getting the turning points, one will be negative and one will be positive, or maybe one will be small, one will be big. Maximum means the biggest ones. You must choose the biggest answer as the correct answer. So think about this, use a textbook, whatever the case might be, work on it, and then look at my solution. So looking at this question, you can see you have a rectangular shape. The first question says express the breadth in terms of the height. Okay, so that's quite simple. All you have to do is read what it says on the sides. So looking at the dimensions, you have HB, HB at the bottom lowest line, okay, of the shape. So you have HB, HB. So this means there's two H's and there's two B's. So 2B plus 2H is equal to the measurements on the top, which is 80. Go back to the question. The question says express B. So then it's trying to say make B subject of the formula, okay, in terms of H. So that means H is going to be in there as well. Okay, but it's saying make B. So express B as the subject of the formula. That's what that means. So that would be 2b is equal to 80 minus 2h. So moving plus 2h over to the right hand side. Now we have to make b subjects of the formula. So to make b subjects of the formula, we'll have to divide everything by 2. And then simplifying that, 80 divided by 2 is 40 minus h. 8.2, it says show that the volume of the box is given by V is equal to 2h cubed minus 100h squared plus 800h. 3 marks. So first starts off with what is the volume that you know. A formula for volume of any rectangular or box shape, right? It's going to be 3 dimensions, so length times breadth times height. That's common sense. Now look around and see what was the first question. What did they ask for? They asked to find B, right, in terms of H. So this would mean you could substitute it in to this other question. Think about it. Okay, and then now we have HH, which means that can be multiplied out using distributive, not a problem, but the L seems to be a little bit of a problem. So where are you going to get the L from? So go back to the diagram and look at it. Looking there nicely at the vertical and 20, notice you're going to get L plus 2H is equal to 20. Make L subject to the formula. You will have L is equal to 20 subtract 2H. That's right. Subtract 2h plus 2h will become minus 2h. We can now substitute the L where L is in the equation. Okay, then the next step will be to FOIL all of that out, and this is how you will get it. 40 times h is 40h and h times h is h squared. Next thing is a binomial times a binomial. Multiply all that out. Okay, do change that to 40 minus h squared, arrow times in the middle. Then you're going to FOIL it out. Foiling all of that out will give us, so 20 times 40 will give us 800h. Then we're going to say 20 times negative h squared. Next step is 2h times 40h. And a negative times a positive is a negative. Then the last terms which is minus 2h, and negative h squared, multiplying that out, a negative times a negative is a positive, and that will give us 2h cubed. Then all we have to do is rearrange it to look like 8.2. In the center we have like terms, so that will be 100h squared, but a negative 100h squared. Do use the calculator for all integers. Next we'll have plus 2h cubed. Next we'll have plus 800h. Okay, and now it looks exactly like the original. Right, read question 8.3. It says find the numerical value of h that will give maximum volume of the box. So there we go, it's becoming like the parabola again. So you're going to have to do a derivative on that, and then let it equal to 0. Right, so let's look at the first term. 2 times 3 is 6. And then we have to subtract 1 from the exponent. 2 times 100 is 200. Multiply that by h. Power 2 minus 1 will give us 1. So h to the 1, we don't write the 1, right? Then we have plus 800h. So that will become 800. The 8 will drop. Let me explain why that is. Move the 1 to the front of 800. And then subtract 1 from the exponent. What will happen? You'll get h to the 0. And h to the 0 is 1. So 800 times 1 is 800. I hope that makes sense. Trying to factorize that, we can't. So then we have to use the quadratic formula. Our a value is 6, our b value is minus 200, and our c value is 800. We will then substitute that into the quadratic formula as it stands. So substitute that and try and get the correct answer. So substituting in, that's what we have. Okay, simplifying it, we got the two values of h. Okay, do make a small correction there. That was negative 200, not positive 200. So it's negative 200, and that will give me positive 200. Okay, those are our two values for h, 4,64 and 28,69. We will then take them and substitute them into the original equation and get two answers, choosing the maximum answer for our answer. So substituting both those values into the original equation, that's the one right on top, and we will get two answers there. Choose the one that gives a maximum answer. So the very first question, the first one, 464, the answer is 1758,83 centimeter. Okay, so when we put in 4.64, that's our answer. And with the next one, we get a negative answer. Do note that the question said the maximum, okay, for maximum volume. So it has to be that one. So the answer we're going to choose is 4,64. That is the correct answer. And this will give us a maximum volume for 4,64. Right, and that's answering the question. Notice the question was 8.3. Determine the numerical value of h, which will maximize the volume of the box. Okay, so determine the numerical value of h, and that's what the answer is, 4,64. That will give maximum volume. I hope this makes sense. Happy learning.